Hello, everybody. I'm Abhijit Mukherjee at the Indian Institute of Technology, also known as IIT in Kharagpur, Kolkata, in India. And I'm an hydrogeologist uh, who works with groundwater. And for the last about a decade, I've been working with Indian groundwater systems. So, in the next few minutes, I'll give you a snapshot of how the Indian groundwater um, what is the scenario, and how things are happening in real time. So I start with this slide where I show you some motifs from some ancient legends or myths of India, where we see the usage of groundwater even in a legend back about 1000 years BC. So India has been using groundwater, or Indians have been using groundwater for more than last 1000 or 2000 years. And if we look at the history of India, you can see there are enough examples in the historical archives, uh, let be the Indus Valley civilizations or in other parts of the country, where groundwater has been used over and over again to make what we know the great civilization of India is. Now, if we move fast forward to modern India, we get to see that groundwater is getting used in every corner of life, from drinking water to sanitation to household needs to industries to urban structures and whatnot. So, at present, about 8% of India's GDP is dependent on groundwater. So, that makes it extremely important. Of this, um, about 90 of about 85% of the water is actually used for food production, and the rest, about 15% or less, is actually used for drinking water purposes, industrial needs, energy production, and so on. So a whooping 85% of the water is required for food production. So when we are talking about groundwater, it's just not the water we are talking about, it's also the food that we are looking for 1.3 billion people. So what are the issues of groundwater in India? Well, as the summer comes in and we are almost at the end of the winter, although it's not in Alberta, uh, we are also already seeing the water scarcity. And every year, parts of India now see this kind of pictures where thousands of people would go for one well to get their water, and the croplands are drying out, foods are not getting produced. It's a mess everywhere. But at the same time, other parts of the country would have the water excess and flood. So we think like flood is only caused by precipitation or rainfall, but actually much of the flood is caused by groundwater. Now, whether we have excess water or have a water scarcity, we are suffering from drinking water security. So we need to have a security of drinking water availability across the country, and that becomes one of the main work that we, as a hydrogeologist, are involved in to find out sufficient drinking water through groundwater sources. And then, if you don't have good drinking water, you are going to end up with this. These people that I'm showing you the photographs are just suffering from drinking bad water. These are poisoning from arsenic, and these are real photographs that I took it myself in the field. So things are not sufficient to just pour out of the tap. You need to have good clean water for your survival. So all this can possibly change with the climate change. Now, we don't know what climate change is going to bring us to, but one thing we definitely know, that if climate change do happen, water sector would be one of the first one to get hit, and possibly we are seeing some of the early signs of that. So in the last about a decade or so, since I've been working in the Indian subcontinent on issues of groundwater, one of the primary things that we're looking at is how much groundwater is available in the Indian subcontinent and what is the future. And of that, how much safe groundwater is available for human consumption. Now, if we try to understand the groundwater, we need to understand the geology at least a little bit. So the map on the left-hand side shows you a simplified version of the geology and so the hydrogeology of the system, where you see the bright blue areas, which indicate you the places where you have 70% of the groundwater being reserved. These bright blue areas, which are adjoining the great Himalayan mountains, are called the Himalayan forelands, and the three mega rivers, the Indus, the Ganges, the Brahmaputra, bring out all the sediments from the Himalayas and make this bright blue geologic formation called the Indus Ganges Brahmaputra Basin. Um, is the largest groundwater repository of this area. Now, this is also one of the largest groundwater system of the world, and it hosts almost like more than 1 billion people surviving on groundwater and the food production from this area. Now, if you look at the map on the right, you would see that the same areas are poisoned by naturally organic pollutants. And these include arsenic, this includes fluoride, salinity, and whatnot. So just having sufficient groundwater is not good enough. You need to have groundwater of sufficient quality. So what we did, we have been working with NASA for the last several years, and we have been working with the NASA mission called Glace. So these two satellites, Tom and Jerry, were shot out in 2002, in the 17th of March 2002, and initially it was thought like it will go on for 5 years, but eventually, as it happened, that after 15 years it's still working, and the second generation Grace satellite just went in. They work at a distance of 220 kilometers at an elevation of 500 kilometers, and as they move on, they measure the gravity change on the Earth's surface, and this gravity change, in turn, actually give you a measure of the groundwater changes over a very short period of time, and thereby tells you how groundwater is changing over a place across the world. Now, for India, this is how it looks like in the last about a decade, a little more than a decade. And what you can see that across India there are different colors for different years, which tells you that there are interannual variability. So if we look through the years, you would see there are changes of color. So blue is good or violet is good and red is bad. So if you have more groundwater, it is blue. If they have less groundwater, it is bad. So more toward the red. So if you look at this map, you would see that over the years, the Indus Ganges Brahmaputra basin, which is the main aquifer system of the Indian subcontinent, have become from blue to red over just a period of about 10, 12 years. So a billion people are now having insecurity in terms of groundwater. Whereas in contrast, just to our amazement, parts of the southern and western India actually have shown some effects of replenishment. Now, we would be expecting that groundwater is slowly depleting because India is the largest consumer of groundwater across the world, much more even the second and third one, which is US and China. So yes, of course, we would expect that the Indian groundwater would be depleting, but this replenishment brings our new story to the whole gamut of things. So what we did is we separated out the areas where we have groundwater storage decrease, which are the red areas, and we separated out the areas where we think groundwater storage has increased over the time period. And we think these areas with red mark on the map are what we call groundwater drought. So India is going through a groundwater drought, at least parts of India. So much of this drought actually is caused by high-yielding crop varieties. So if you have high-yielding crop varieties being planted since back in the 1980s and mostly from 1990s, you have more need of groundwater than before. Much of this groundwater is being used for flood irrigation. So you are using much more water than possibly you would be needing. And all of this would also lead to conversion of water intense cash crops. So people at many places in the country would be converting their traditional crops to cash crops, which are much more water guzzlers. And all of this would essentially lead to severe groundwater exploitation. Now, some people do talk about climate change impacts. Now, I'm not a climate change scientist, so I would refrain from commenting on it. However, I doubt that within 10, 15 years, you can really see a climate change impact. Now, on the same note, as a silver line, we do see chances of groundwater replenishment. Now, this is a new finding, and we were not very aware of this before. We think that groundwater replenishment is happening. The satellite data actually matched out quite well with the ground data that we measured from the about 3,000 wells across the country from 1996 to 2015. So there is a good match, and it seems that yes, there are some areas which are really getting benefited from groundwater replenishment. How is it happening? Well, I think much of it has happened by, unknowingly, people not even understanding that they are replenishing the groundwater, and that includes recharge canals, putting water to dry riverbeds, infiltration ponds and tanks, and sometimes more focused efforts like check dams, artificial recharge, rainwater harvesting, and so on. Now, in India, over the last few years, there also have been, several large-scale water management structures have been built, like large dams. Now, that might also have influenced, the water preservation downstream. But what's more interesting is in some countries, or sorry, some of the states, they have actually restricted the usage of electricity for agricultural use. And that in turn would ration the electricity that would be available for turning on the pumps. And these pumps are the one which would be taking out the groundwater from the subsurface. So if you are stopping the pumps, you are actually benefiting the groundwater. So over the years, we found out that this has actually resulted through groundwater replenishment in some parts of the country. So through a very, back of the envelope calculation, you can see that there are about 13 cubic kilometers of groundwater being abstracted from India every year, whereas about 3 cubic kilometers of groundwater is replenishing. So still there is a net about 10 cubic kilometers of groundwater that is going out, which is non-renewable. So unless, we as Indians, common Indians, start taking immediate management strategies, India is going to get dry, more dry than the Sahara in quite near future. So our work got appreciated in various levels, including the ministry, including various media sources, and we think like we can make some difference by our scientific study and integrating the policymakers with the outcome of these studies. Thank you so much, and I'll really appreciate if you can reach me for any question and further proceedings. Thank you.